Today in Capechi's Corner, we are going to look at rate of change, and today's day one. So the rate of change is how a quantity is changing with respect to change in another quantity. So again, we're all talking about how things are changing as they go in comparison. The rate of change when we're talking about slope, when we talk about rise over run, and we'll get through that, and we'll talk more about that as we proceed through this unit. All right, so let's take a look at our first example. So in this particular lesson, we're not going to do the slope formula, which you may have done in previous classes. We're going to get to that on our second day of this lesson. Today, we're just going to look at tables and graphs and compare them. Okay, so on the first one, it says find the rate of change of the function by using 2 points from the table. So again, I'm talking a lot about this year about really paying attention to the words that are going along with the math problem. So we have the amount of flour is X, and we have pancakes, which is Y. So in looking at what's happening and changing, as each flour cup goes up 2, we're also increasing by 2 here. 2 is a change here, 2 is a change here. What's happening with pancakes? We can make 12 more pancakes each time we add 2 more cups of flour. So this is what we're working with, the change of Y. So this is Y, right? What happened? Now, again, you can go either down or up the table. You just have to be consistent. And in this video, I'll kind of go both ways so you can say it. Okay, so the change in Y, what happened there? We went up, we could make 12 more pancakes. And then change in X, what happened is we were adding 2 cups of flour. So when I simplify that, it's 6. So what does that mean? Well, it's really 6 over 1. And again, I like to use the words. So for every cup of flour, we can make 6 additional pancakes. So again, that's kind of filling the sentence here. You can make 6 pancakes for each cup of flour. All right, let's take a look at our next example. So this time we're going to look at a graph. So Miami Dolphins average ticket prices. Okay, so they have the years down here, and then we have the price over here. What I did just to save some time is I pulled out the information. So 2009, the ticket price was $66.74. And then in 2010, we can see that price definitely went up, $70.54. Okay. Now, this is a 1 year change, right? So when we subtract that, we're going to get $3.80. So we know that's just 1 year. So $3.80 per year, that's what the change is, the rate of change. So the ticket prices have the greatest rate of change when we're looking at this. Where do things spike very, very quickly? Well, they happened. This was a downward spike. This went down very quickly. And so we're going to say between 2013 and 2014, that was the biggest rate of change and the negative value. So between years, was there a negative? Well, we already said 2013 and 2014, that was a negative change there. And the other time we have a little bit of a spiral right there, spiral down. So that's 2010 and between 2010 and 2011. So again, just kind of getting used to reading the graphs and being able to interpret them. Okay. All right, let's look at our next example. And this questions we're looking for a constant rate of change, asking whether the function is linear. So linear means line. So if we have something like this, it doesn't even matter. If we have something a little more flat, a little bit, or if we have something going the other way, it doesn't matter. But in any of those lines, we have a constant rate of change. A constant rate of change is when it's linear. So what I did was I kind of marked off what we had, right? This time I went from the top. And in my X values, I went down 3. So that's why I have that. It's a -3. In my Y values, I added 2. Okay. So because each one went down 3 with the X's and went up 2 with the Y's, it's definitely constant. So we can notice that the rate of change for each point shown is, and again, we're going to do Y over X, change in Y. That triangle means change over change in X. So we have +2 over -3. We usually put that negative on top. So -2/3. So the rate of change, because all the rates of change between the 2 points were constant. So because they were constant, meaning they were the same, the rate of change is -2 over 3. Again, we know that it's linear. So linear, yes, it's linear. Okay, let's look at another one. Okay, determine whether the linear function is linear. So we got to ask the same thing. So this time when I did my values. This time I started from the bottom just to show you that either way it doesn't matter. So I subtracted 7 each time. So that was the same on my x. But when I went to my y values, sometimes it was a difference of -2. Sometimes we were subtracting 2. Sometimes we were subtracting 3. So it's definitely not constant. So this one is not linear, right? This one's not linear. This one's not linear. It's not going to be a line. Okay. Now, again, we do change in y and change in x. What happens is the change in y is here. Sometimes we had -2, and our change in x was always -7. So that slope, a negative over negative, gives us a positive. Sometimes our y's were -3, right? And the x's was still -7. So that would be +3/7. So sometimes the rate of change is 2/7, and sometimes it's 3/7. So that's why it's not a linear function. All right, let's take a look at this last one. This one's a little bit different. It says complete the table so that the function is linear. So when we say linear, we mean a constant rate of change. Constant rate of change, which again means that the values are going to always be the same, both in x and y. So in looking at my x value, I notice I have to fill in these two blanks up here. I noticed that I was subtracting 0.5 every time. So in going to the reverse, I'm going to add, right? So I'm going to add a 0.5. So that's going to be 11.5. I'm going to add another 0.5. That's going to give me 12.5. That's my x values. Now for my y values, I looked right here and I realized as I went down, I was adding 3.25. So I'm going to keep going there. Add 3.25 to 10.75, I'm going to get 14. I can go back up to this value 1, and I'm going to add 3.25 there, and I end up with 4.25. Okay? Thanks so much for stopping by today. You have a great day.